This lesson is assume that the matrix A and B are row equivalent. Without calculation, list rank A and dimension no A. Then find basis of column A, row A, and no A. Okay, so one more time. When it says A and B are row equivalent, that means A is the original matrix, B is the solution or answer from A after row operation. One more time. A is the original matrix. B is the solution from A after row operation. Okay, so that's what it means when A and B are row equivalent. So that's what A stands for. Part one. Part number one, matrix B is echelon form. That means in simple word, B is the solution of A after row operation. Okay, so that's what one means. B, okay, so that's part one. Part two, number two, there are three pivot columns. So I have 1, 2, and 3. So one right here, one right here, one right here. Since I have 1, 2, 3, dimension of column A is 3. There are three pivot row. So here's 1 row, 2 row, 3 row. One more time. Here's 1 row, 2 row, 3 row. So therefore, dimension row A is 3. There are 2 columns without pivot. So here's the first column, no pivot. Here's the other column that has no pivot, which is right here. Okay, so right here, there's no pivot, and there's no pivot right here also. So 1 column, 2 column with no pivot. So therefore, dimension no A is 2 because there are 2 columns without pivot. Okay, next, the basis of column A is the pivot column. So here is the column that has a pivot. Here's a column that has a pivot, and here's a column that has pivot. So column 1, column 3, and column 5. But we're going to use A, not B. Pivot 1, column 1, pivot 2, column 3, pivot 3, column 5. So we're using column 1, column 3, column 5 from A. So here's the first one, here's the second one, and here's the third one, which I wrote it over here. So here's the first column, second column, and the third column. You only use the column that has a pivot. Next, number 6, pivot row A. Okay, so we will use B. So here's the first one that has a pivot. Here's the second one that has a pivot. And here's the third one that has a pivot. So we're only using the first row, second row, and the third row, which I have here. First row, second, and the third row. Okay. Next, number 7. Number 7, we're going to find the basis of no A, and then we're going to use row operations. Okay, only the first 3 row because there are only 3 pivot. Okay, we're only going to use the first 3 rows because there are only 3 pivot. Now we're going to use the matrix A because it says no A. Okay, so based on this, here is my first pivot, here's my second pivot, here's my third pivot. So we're only using the first, the second, and the third row to find the basis of no A. Okay, again, we're only using these 3 rows because these 3 rows only these 3 rows has a pivot here, here, and here. The last row, there is no pivot. So we're using the first, the second, and the third. Okay. So here is the operation right here. So we need negative 2 be 0, negative 3 be 0. So opposite of negative 2 will be positive 2. Opposite of negative 3 will be positive 3. So 2 times 1 is 1. Subtract 2 gives me this 0. 2 times negative 3 is negative 6. Plus 6 gives me this 0. 2 times 4 gives me 8. Subtract 6 gives me this 2. 2 times negative 1 is negative 2. Plus 1, negative 3. 2 times 9 will be 18. 18 plus 10, 38. Okay. Next, 3 times 1 is 3. Subtract 3 gives me this 0. 3 times negative 3 is 9. Negative 9. Negative 9 plus 9 gives me this 0. 3 times 4 is 12. Subtract 6 gives me this 6. 3 times negative 1 is negative 3. Plus negative 6 gives me this negative 9. 3 times 9 will be 27. 27 subtract 3 will be this 24. Okay. We need this 2 to be a 1. We need this 6 to be a 1. So multiply the reciprocal. Multiply the reciprocal. Okay. So I have a half. So 1 over 2. 1 over 2 times 2 gives me this 1. 1 over 2 times negative 3 gives me negative 3 over 2. 1 over 2 times 38 is 19. Okay. 1 over 6 times 6 gives me this 1. 1 over 6 times negative 9 gives me negative 32. 1 over 6 times 24 will give me this 4. Okay. Now we need this to be a 0. So we multiply negative 1 to row 2, add to row 3. So negative 1 times 1 is negative 1 plus 1 gives me this 0. Negative 1 times negative 3 over 2 gives me positive 3 over 2. Subtract 3 over 2 gives me this 0. Negative 1 times 19 is negative 19. Subtract 4. Negative 19 plus 4 gives me negative 15. Okay. Now we need this negative 15 to be a positive 1, which I have here. So we're going to multiply the reciprocal of it and then put another negative because I need a positive. So negative and negative be positive. So 115 times 15 gives me this positive 1. Okay. Next, right here, if you see this pivot right here, there's a 0 right here, so we don't have to worry about that one. But if there's something here, we need to make that a 0. So one more time, as you can see that there is a pivot here, and up here is already a 0, so we don't have to worry about it. Okay. Now come down to this one. This has a pivot, so we need this 19 to be a 0, and we need this negative 17 to be a 0 as well. Okay. So one more time, we have a pivot here. If this is a 0, then leave it alone. If I have something up here besides 0, I must make it a 0. All right. So same thing as down here in this column. Here I have a pivot. I need this 19 to be a 0. I need this negative 67 a 0. Okay. So opposite of 19 will be negative 19. Opposite of negative 67 will be positive 67. So negative 19 times 1 is negative 19 plus 19 gives me this 0. 67 times 1 is 67. Subtract 67 gives me this 0. Okay, so one more time. Here I have a pivot. This has to be a 0. If it's not a 0, you have to change it to a 0. Same thing here in this column. Here I have a pivot, but I have something that is not 0, so I need to change 19 into 0. Same thing with this 67. It has to be 0 as well too. Okay. Once it is 0, then we are completely done. Now write it in the terms for each of them. Okay. So here we go. x1 minus 3x2 plus 5x4. That's what I have here. x1 minus 3x2 plus 5x4 equals 0. That's what I have here. So solve for the first term. So negative becomes plus, plus becomes negative. Just move it to the right side. Next, I have nothing here. This is my x2. This is x2 right here. Since there's nothing, free. This is x3. So x3 minus 3 over 2 x4. That's what I have here. And then move this negative 2 over, so become positive 2x4. Okay. This right here, x4 right here, x4 right here. Since this is a 0, so free. Okay. All right. So, and this is x5. Since there's nothing, so also 0. So x5 equals 0. Okay. So here we go. Again, to its term. This is x1 right here. This right here is x2. Then there's nothing. Free. This right here is x3, which is here. This right here is x4 because it's a 0, free. This is x5, so x5 equals 0. Okay. Now, based on what we have x2 and x4 only. We only have x2 and x4 only. So we will write one vector for x2. We will write the second vector for x4. Again, we only have x2 and x4. So we will write the first vector for x2, the second vector for x4. Okay, so first term for x2, which is this 3. Second term for x2, because it's free, we write 1. Third term for x2, none, because there's nothing, so 0. Fourth term for x2, 0. Again, there's nothing. Fifth term for x2, 0, because there's nothing. Okay, now do the same thing with x4. First term x4, which is this negative 5. Second term for x4, 0, because there's nothing. Third term of x4, which is here, 3 over 2. Fourth term of x4. This is fourth term of x4. Since it is free, 1. Fifth term of x4. There's nothing, so 0. So these two vectors are the null. These two vectors are the basis of null A. Okay, so just be careful of listing out each term based on its variable. Okay, so be very careful of that. Again, when it says A and B are equivalent, that means matrix A is the original. B is the solution or the answer from A after row operation. Okay.